mathematics started with numbers of objects we can count. Some numbers like 0 or -2 are harder to represent but are still real numbers. Real numbers can be represented on a number line, where positive numbers are to the right and negative numbers to the left. Adding is represented by walking forwards and subtracting by jumping backwards. When adding or subtracting a negative number, turn 180 degrees and face towards the negative direction. But what happens if you turn through an angle that is not 180 degrees? What is out there? The answer is the complex plane, home of the complex numbers. Complex numbers have a real component, represented by the coordinate on the x-axis, an imaginary component, represented by the y-coordinate. The term imaginary was coined by Descartes in 1637 and intended as an insult, as he didn't understand the great practical importance of complex numbers. He wasn't alone. Back around AD 75, Heron of Alexandria, who also invented the vending machine, was studying the frustum of a pyramid, which is like a pyramid with the top cut off. In doing this, he almost discovered imaginary numbers. He was using a formula to find the height of the frustum of the pyramid, but when he tried the numbers 28, 4, and 15, he got the answer the square root of -63. At this point, he did what most of us would, and just pretended the negative sign wasn't there. But negative square roots are the basis of imaginary numbers. Much later during the Renaissance, when mathematicians would have mathematical duels where they competed to solve problems, the square roots of negative numbers could no longer be ignored. Solutions to deceptively simple problems, like find two numbers a and b that add to give 10 and multiply to give 29, required the square roots of negative numbers to provide solutions. Later, it was Carl Gauss who assigned the letter I to represent the imaginary unit, the square root of -1, which we still use today, except for the people who use j. So back on our complex plane, the imaginary axis has the units of I. So the answer to our problem, a plus b equals 10, a times b equals 29, would be 5 plus 2i and 5 minus 2i. And finally, remember that complex numbers are all fun and games until someone loses an eye. Thank you for watching.